Assalamualaikum and hi, my name is Nurul Binti Ahmad Afandi. So from this mini project of control system, we need to create a transfer function with at least 1k, 2 poles and 3 zeros. So we have created our equation of transfer function. So from our transfer function, we put the value of k 500, a negative 2, b negative 3, c 6, d 50 and e 7. So we transfer this transfer equation into the Scilab code. To find in the Scilab code, we need to find the gain crossover frequency, phase crossover frequency, gain margin, and phase margin. So after we run the Scilab code, we got the amplitude response and this phase response graph. So from this graph, we are able to find the gain crossover frequency, which is 79.1669 dB, phase crossover frequency 0.60972 dB, gain margin negative 11.3429 dB, and phase margin, which is 97.8133 degree. So from the gain margin is negative margin that shows how much the control system will be reduced. So next, for the next question, we need to use the lead compensator to further improve 10% of the current phase margin of the response. So we have calculated manually at first. So by using to find the new phase margin, we have to take the old new margin and times it 110%. So we obtain 107.519% degree. So to find the alpha max, we have to take the old phase margin minus with the new phase margin and plus 15. So we obtain 24.781. So next for alpha max, we have to inverse sign, which is we have to alpha minus 1 and divided by alpha plus 1. So we have by using the calculation of mathematical, we obtain the alpha 2.44. So we substitute the alpha to this formula and we obtain 0.0018. Then we have to find the GS. We substitute all the value that we got above. So we got 1 plus 0.0197s divided by 1 plus 0.0081s. So next, we use the Scilab code for the compensator. We have to divide it by we have to plus this num C and den C, and we have to divide between the num C and the den C. So after we run, we got the result for the lead compensator, which is this graph, and we are able to find the lead compensator phase margin and gain crossover frequency, which is 96.643352, and the gain crossover frequency 192.54059.
Okay, Assalamualaikum. My name is Aswadi and I want to discuss the question 4. Okay, for question 4 is use both leg compensator to further improve 10% of current phase margin of the response. Show the final transfer function of the compensator at its phase and amplitude response. You can use Scilab to draw the board. Okay, for step first, we have to find the new phase margin. There is two PMU. First is 8. First value is 81.0840 is have to times 110 divided by 100, and then we get 89.11792 and have to plus with 5. Okay, then we get 94.19. Okay, and then negative 1 plus with 90. And then we have to plot in the Scilab for point negative 85.81. And from 85.81 to we have to find the radian. And the radian of 85.81 is 1.36. 3989.396 radian. Okay. From radian 1.396 radian, we have to find the for the dB. The dB is 5.272 dB. Okay. The formula of dB is 20 log 20 log A. Okay, so for dB is 5.272 is equal with 20 log A. Okay, and then we have to find the A. So 5.272 is 5 divided with 20 and equal to log A. And log A, and we get the log A is we get 0. 12636. Okay, so the A is 1.835. Okay, next we have to find the Z is equal to 0.2636. Z is 0.2836 divided with 10, and the Z is for the formula of transfer function is G C equal to 1 plus RS divided by 1 plus alpha RS. Okay. For formula R is we get 1 over with Z. So the Z answer is 0.02826. So 1 divided by 0.02826, and we get 35.339. Okay. So next, after know the formula transfer function, and we can exchange the value of R and value of A. So the 1 plus R is 35.39 as divide 1 plus alpha is 1.8, and times with the R is 35.39 as the answer we get is 1 plus 35.39 as divide 1 plus 64.9328 s. This is the answer of transfer function. After calculate manually, we have to find in Skylab. And for the Skylab, we get this. Okay, the picture we get this from the Skylab. And the plot of and the graph is like this. Okay, after find the result of Skylab, we have to find the phase margin after improvement 10% from current phase margin use Skylab. Okay. After write the coding of transfer function, this transfer function, and then we run. And after run, is have to write this sentence. First, the GM, comma PCF equal to G underscore margin transfer function, and the answer of GM is negative 6.0574 plus. And after that, we can get PCF. PCF is 0.60x614. And then for P margin transfer function, the PM is 93.64510. Then the GCF is 0.2221279. Run response to get into the graph. Okay. This is the coding. To find the RAM response, we have to add RAM response claim TTF this. Okay. After we write this sentence, that we get is like this. Okay. The X is 0.105, Y is 0.105, and Y is 0.006. And we get like this. Okay, thank you.
Hi, my name is Nurul Izuani Binti Saharuddin. Okay, I will explain which compensator that can be used to achieve a 10% improvement of phase margin. First, let me explain the definition of this a lead compensator and a lag compensator. A lead compensator is a type of compensator that can be used to improve the phase margin of a control system. A lead compensator adds a pole at higher frequency than the gain crossover frequency. These poles add phase lead at the gain crossover frequency, which increase the phase margin. A lag compensator is a type of compensator that can also be used to improve the phase margin of a control system. A lag compensator adds a zero at a lower frequency than the gain crossover. This zero adds gain at the gain crossover frequency, which can increase the phase margin. So here is our phase margin, which is 97.8133 degrees. So after we calculate the new phase margin, in question 3 we get the 107.591 degrees, and for the leg compensator in question 4, we get a 94.19 degree. So we can conclude that the lead compensator is achieved 10% improvement of phase margin because it closer to the 97.8133 degree. So the lead compensator has a zero at lower frequency, as I mentioned before. So the gain crossover frequency which increase the phase margin. The zero in the lead compensator closer to the gain crossover frequency than the poles in the lead compensator, which means that the lead compensator adds more gain at the gain crossover frequency. So in this case, equation 3 and 4 for the lead compensator is able to achieve a 10% improvement in a phase margin because it adds more gains at the gain crossover frequency. So in equation 3, the phase margin is 97.81 degrees. So by using the lead compensator, the phase margin can improve 10% to 107.591 degrees. This demonstrates that the lead compensator is more effective at increasing the phase margin compared to the lead compensator. So that's all from me. Thank you.